Hello.
Yeah, hi Rajni. Am I audible? Hello.
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 Huh, sir.
Hi. Am I audible now?
Yeah, I can hear you, sir. Yes,
Okay. Let me present my screen.
yes, sir. And actually, last week, so there is a one
Yeah, go ahead.
question mistake is there, sir. Last question.
Last week, right?
Last week, yes, sir. Like there is a
Please
torque
see.
is there, na electromagnetic torque T equal to TSH plus J into d omega by dt.
Right.
That question is actually so many times we calculated. Even in class also we got the answer 0.533. And when I
Uh-huh.
did my calculations, I also got the same thing 0.533. I given that value, but there it's the given limit is 0.8 to 0.9. That is what question number 9 to 10, sir. Question number 9 to 10.
Sure. We will revisit those questions and we will confirm whether answers are
Only
correct or
one
not.
question, sir. Not much this week only one question is sir.
Okay.
And last week questions already raised a query.
Uh-huh.
Uh,
So last week question number 10.
last question number 10, sir. So there is some voice is coming, sir, background voice. It's at my side or
Let me check. Or maybe a kind of fan kind of noise or like connectivity
ah,
issue.
now it's settled, sir.
Okay. Now is
Earlier
it
it is
fine, right?
some water floating like that type of sound.
Okay. Hmm. So I think these question 9 to 10, you mean you have only doubt in question 10, values, numerical values.
Yes, sir.
It is similar to question number 8, right? So in 8 you are getting correct.
10, sir. Last one, 10.
Last one 10, I agree. But you see the question number 7, that is also
Mhm.
same question, right?
Oh, yes, yes, yes. The same type of question.
And in
Yes.
question 7 you are getting correct answer.
Yes, the correct answer.
Okay, so let us see.
W2 minus W1 by delta T, we got 3,333.33 is the correct, sir.
Okay.
When coming to
Okay.
electromagnetic torque, TH.
Uh-huh. Then
Uh,
let me calculate step by step, then we can verify.
yes, sir. Yes,
Yeah.
yes.
Uh, Question number 10. Yes, yes, dw by dt is given omega 1 minus omega 2. So 400 minus 200 minus 200 divided by 0.06. It is 3333.33.
Yes, sir. 3,333.33.
Yeah. And I
Radians of
think that is coming in the range. Now regarding torque, J d omega by dt plus T
SH.
right. So TSH is given as zero point 0.2
Yes, sir.
and J is given as 1 into 10 to the power minus
Minus 4.
1 into d omega by dt is nothing but 3343.6. Okay, now into 10 to the power minus 4. So 1 by 3, 0.33 plus 0.2. Yeah, it's wrong. 0.533.
3.
Yeah, Newton.
But that answer is wrong, sir.
Answer is wrong, exactly. So,
They given the limit point 8 to point 9. If you can check, it's the point 8 to point 9, sir.
right, right.
They given.
So, answer is certainly wrong. You can challenge or you could wait. I think they have the lead solution till week 6, I guess.
Till the 6th, there it is a solution, sir. Yes.
So, if you had any, mismatch of answers till the week 6, then you could, discuss on the group and
Mm.
please wait for some time till they release all the week's solution.
Yes.
Or you could also message now, so there is no harm in messaging in the group. Okay, okay, so this answer is certainly wrong.
Yes, sir.
Any other question? Did you face
No,
any?
sir. Only one question is wrong. That is only this question, and that's it, sir. And remaining everything is correct.
Okay, great. So then let's move on to the this week's content.
Yes, sir. Wait.
Okay, so first, this week I think most of the questions are related to theoretical problems, and those are associated with finite element analysis. So, how do you understand finite element analysis? In what way that we are going to, see with the help of certain problems, so that it will be helpful in solving assignments. So, let us move. Start from question one. Okay, so which of the following is a challenge associated with FEA in motor analysis. Okay. Option A, lack of or limited rather limited computational power is one challenge. Another is lack of stable materials. Option for simulation. Uh, Third is inability to simulate mechanical stress. And D is high cost of software. So if you see all the four options, you will feel like most of them are correct statements, but we have to choose most appropriate option for this particular question, that which one is the major challenge associated with it. Right. So let us focus on first option. What does it says? So right, uh, it is a powerful computational tool. Since if any tool, any software, if you pick, it is a powerful tool. So it has computational power. That is certainly it has, because to do analysis, electromagnetic, and all FEA with fine meshes. If you do not have enough computational power or enough resources, then what will happen? It will take so long time. Like in certain software, I have seen like magnet software. It takes sometime like 2 days, 3 days for simulation. So it is necessary nowadays to simulate faster, quicker. uh, you require high computational power, and there comes HPC kind of system plays a crucial role if you are in any industry or in any institute. HPC, most of the ACA softwares are now offering services with HPC. So HPC has become nowadays necessary to run these kind of software. But yeah, high computational resources, I would say key it is much needed. So like three, it is very important. Like the second is uh, lack of suitable material option for simulation. So how much time does it take for Altair Flux software? You have worked with that software. So generally, how much time does it take?
Actually, it's depending upon the 3D or 2D, sir. For 3D, it's there, and more complex it is there. It will take 8 hours.
8 hours, right? And with a single core, like single system, right? No HPC and all.
HPC is there, sir.
Oh, with HPC, it is taking 8 hours.
8 hours. That too is a complicated one. Actually, in Flux, if we want to develop, there is a two ways. One is the through overlay, and the
Yes.
second one is the you can create your own DXF file, and you can develop the 3D model. It will take 8 hours. If it is a overlay, it will take 3 hours, 2 to 3 hours,
Okay.
based on how many electric cycle you are giving.
Right, right. Basically, how much fine meshes you are providing, right? Indirectly, you are
No,
referring to that.
mesh also, yes, sir. There is an option is there because mesh is not a big task for me because coming to mechanic, it's a big task. There is a mesh, automatic mesh is there.
Okay.
Oh, defining the physics, giving the circuit, assigning the materials. So these things will take time for me.
Okay. No, like generally, computation time of any software, any FEA analysis, if you are going to perform, the finer the mesh, the higher time it will take.
Higher the accuracy, yes, sir. Actually,
Yeah.
you can select your finer mesh also.
Yeah. So
There
that's
is a
what I'm
three
saying.
types of meshes are there,
Uh,
very dense mesh, and if you have more time, like that. how many
So in
parts you can.
in 3D, what is happening that your meshes are also protruding along the z-axis, right? So
Yes,
in
sir.
that way, I am saying ki your mesh is going to increase for 3D analysis.
Yes, it's a 4 hours in the sense my PC is 128 GB RAM.
Oh, 120 GB RAM,
128.
128 GB RAM. That is
128
insanely
GB RAM.
high. Yeah.
Yeah, it's required actually for simulation that much GB
Yeah.
is required, sir.
Yeah. So you imagine like if some student is simulating, they have only one PC with 8 GB RAM, 16 GB RAM, then certainly it is going to take 1 day, 2 day,
Today, yes.
depending on the task. Right? So that's why many times we use symmetrical analysis to just save the time. So we do iterative simulation until we converge to our final design. Then finally, when our design is almost finalized, then we put into full analysis for 3D model, and that takes a lot of time. Like if we do it on daily basis for all the analysis, then you imagine how much time it will be. So computational power is certainly an important option, and it is certainly it will limit how capable or how fast we are doing the analysis. So yeah, second option is, so first option we agree it is a major limitation, right?
Mm.
Now second option is a lack of suitable material option for simulation. So have you faced this issue?
Yes, sir. Now also we are facing same issue actually. What we will do, we never get there's a library is there in every software, so we'll get some materials. If you want to particular material, just you have to compare the properties and you have to select that material. And if you want to create your one, you can create your own material also, but nobody having that data.
Right,
For example, say steel, you have to give the B and H value, BH curve.
right.
Magnet
If
you can get easily BH curve through the in internet or somewhere, but coming to steel, nobody will provide that BH curve. So what we are doing, we are taking relative material to that.
okay,
So material
and
issue is there.
So you are referring that material is available in the market, but no one is providing you the data.
No one, yes, sir, no one. No one will provide the BH curves or these things.
Okay. Okay. And by the way, which steel you are using, if I may ask? Like which regarding which steel you have faced this issue? Any particular example?
Sir, CRCA, that cold rolled. CRCA, CRNGO.
Means cold rolled non-oriented grain, right? Right.
Yes, sir, non-grain oriented. CRNGO. See,
Okay. So
cold rolled annealed copper something and CRNGO cold rolled non-grain oriented.
right. So it is a hurdle, but anyway, you move ahead with different options like whatever is
Mm.
present in the simulation model.
Yes, sir.
Right. So how much difficulty level should I mark for this option?
What is that? But not no pretty, sir.
Uh, I am marking according to the limitation. So, how much this option, how much limit your computational or how much limit your FE analysis? You are getting my point. Like limited computational power is a must thing to have. Like otherwise, it will hurdle or it will obstacle our work by significant time margin. But
Mm.
lack of suitable material, if you do not have data for suitable material, but if you have in mind or by some if you have physical material, then what you can do, you can experimentally achieve certain data,
Mm.
or what you can do, you can find out similar material if it is present in the library. So
Mm.
from there you can, like, let us suppose ki, you are using M19 still, right?
Mm.
M
M90. Yes.
M19 is present in the market. M19 is also present in the
Ah,
software,
in the
many software.
softwares.
Yeah.
Yes.
Now, next thing is that if you want to use materials slightly higher grade, with slightly higher grade, I mean to say like M250, M270, M235, like
Mm.
that, all with cobalt integrated still. Like nowadays, in automotive stator, particularly in the stator core, cobalt integrated laminations are being used. So what they are doing, they are able to make laminations so thin so that your iron losses in the stator will be reduced. Right?
Okay.
So if let us suppose if you do not have any data for that, you you could have similar data like vacuum flux material. Have you heard about that vacuum flux? Let me show you with the help of software. So right now, I hope you are able to see my screen with
Yes,
handset
sir.
AutoCAD software. Yeah. So
Materials.
here, if you go in the material section, okay. So for timing, we are focusing only on steel, right?
Mm.
So see, this is M19 material. If we go in the steel BH curve, so this is kind of a steel BH curve you will be able to see.
Mm.
Okay, and mostly we are concerned about this saturation level where it is being hit, like 1.9 Tesla. After 1.9 Tesla or 2 Tesla, it is almost getting saturated. Okay,
Yes, sir.
and so this is still with silicon, conventional silicon non-oriented grain steel. Now, if you go to the vacuum flux, right, it is integrated with cobalt. It has almost 4 to 5% of cobalt alloy. Right. So
Okay.
what is it doing? It is further pushing the saturation limit. Now you can see that the saturation limit is almost closer to 2.2 Tesla.
Mm.
Right. So here what will happen that you could pump in more flux in the air gap. Why? Because it still is able to endure more flux density. So it will not get saturated. What will happen after saturation, after this point, after 2.1 Tesla or 2.2 Tesla? Because this P is higher, and we know that iron
Or
losses
increase.
are directly dependent to our magnetic flux density,
Yes.
that in proportion to a square or 1.6 times hysteresis or adding whatever you consider. And you pump more current, but it will not lead to increment in flux density, air gap flux density, which is a major factor for torque production. Right. So if you have this much data here for this cobalt and you see corresponding to 2.2 Tesla, how much electric loading is required? 3,990 amperes per meter, right?
Yes, sir.
So to achieve almost 2.3 Tesla, you need only this much electric loading, 3 kiloamp, 4 kiloampere per meter, you can say. Now, on the other hand, M90 to achieve 2.3 Tesla, how much electric loading do you need to inject? That is almost 200,000.
Yeah.
So, see, for cobalt based steel, to feed almost 2.3 Tesla, we need 4 kiloampere per minute. And on the other hand, silicon based steel, it also has silicon integrated with silicon. Now, in silicon based steel, 2.3 Tesla corresponding to 200 kiloampere per minute. So almost 50 times more current you will have to feed to achieve similar air gap flux density. And 50 times means how much times copper loss will increase? Like 50 square times. So that will be 20. So copper loss will increase by 2500 times. So here you will see the importance of material, what material you are going to choose. Right. And nowadays, at least in a stator, people have started using cobalt-based alloy. Yeah. On the other hand, this price of this cobalt-based steel is also 50 times higher than the conventional steel or silicon-based steel. So you have to, optimize key up to how much flux density do you need in your air gap, and how much performance boost do you need according to the price, like how much price you are willing to pay. So that all factors you have to include. So here it comes the importance of material, right? So mostly materials you will get, almost materials you will get. If you do not have, then sometimes you can model, or sometimes you can achieve experimentally. So this is which I feel ki it is a hurdle, but it is not that major hurdle that it will limit your work, right? So that is why I am giving it as difficulty level of very low, like 1 star, right? Chitu, are you getting this point?
Yes, sir, somewhat.
Yeah. Now, a third option is inability. Yeah, sorry. Go ahead, please.
Uh, could you repeat me once what was going on?
Uh,
I joined a little.
okay, okay. So I think some noise is coming from your side. I don't know why, but I got what you are saying. Ki you joined late. So this is what we are discussing in this week's content. Ki all the problems given in your assignment based on FEA. So what happens in FEA software? So the first problem we are discussing ki what are the challenges associated with FEA in motor analysis? So first option we discussed ki limited computational power is a major hurdle here. If you do not have enough cores or enough computing resources, then what will happen to simulate a simple FEA analysis? You will need a couple of days. And for one iteration only, if you need 2 days or 1 day, it means ki you might be knowing to analyze a product based on simulation. It takes almost like 100 to 500 times simulation at least. So if your simulation is going to take only 1 day per iteration, then you assume ki at least 100 days it will take for your entire analysis. If you are acting day and night, and also you are bound to a stuck for that time, so you will not move ahead during that time while your simulation will be running. So you will be sitting idly only, right? So there, this computational powers, play a major role, right? So I hope you got what I'm trying to convey here, right?
Yes, sir.
Yeah. I would recommend you rejoin the session. I think I am hearing some noise from your voice. So you rejoin, you quit here and again join. Then let's see if it is improving or not. And yeah, so B option we just discussed key lack of suitable material option for simulation is not that much a major hurdle, but it is there. Now third option is yeah, inability to simulate mechanical stress. So can we simulate mechanical analysis? Can we do mechanical analysis with FEA? And is it a challenge nowadays?
Okay, we will check in ANSYS motoric and mechanical, no, sir, the stress value and all these things.
Yes, yes. So see here only we can go directly to the mechanical, right? And let us suppose the shaft speed is 3000 RPM, whatever is given in this template, and include magnet with adhesion factor, let's keep 0.5. And now we run the rotor stress model. So see how easy it is to solve mechanical stress with FEA. So you can see that maximum stress is acting here, right? And the data you could see on my screen on the left bottom corner, how stress is varying, or you could also visualize via this legend which is on the given here. So you see the most red section is near the sap. So here, this portion is facing maximum stress. And what is an ideal way? So how will I get to know कि this much stress is below the limit or above the limit? So here, what am I seeing that 0.9 or 1 megapascal is the maximum stress which is faced by this rotor, right? So how would I be able to know that this is permissible or this is fine, or I have to change this design to avoid this mechanical stress? Any idea? Okay. So see, if you go to the material property again, so the as of now we are seeing maximum stress on the rotor core, right? So which material consists of rotor? Uh, yeah. So this material is viewed here now, right? And what is its mechanical property? So its mechanical property is we have to observe yield stress. How much is the yield stress? So the maximum pressure, the maximum stress should always be less than yield stress. Yield stress is the maximum limit which your material could endure. Okay, and its limit for M350 is how much? 305 MPa. And by help of simulation or FEA, how much stress we are getting? 1 MPa. So it is much below the limit. So we do not need to worry about rotor stress here at all at this speed for this particular speed, right? What will happen if I increase this speed from 3000 RPM to 3000 RPM? Let's see. So now you can see that this stress has increased from 1 MPa to 100 MPa. So from 3000 RPM to 30,000 RPM. So speed increased by 10 times. Our stress increased by 100 times. It is not a direct proportional relation, but it will give you an idea that with what aspect this stress will vary. So as you increase speed, your stress will increase. So that's why in synchronous reluctance motor, if we have gone through those lectures, that we could not place as high barriers as we want. Like we could not place 10 flux barriers in a pole, in a small pole. What will happen? It will reduce your mechanical strength because there are so many bridges, right? If I have an example of synchronous reluctance motor, I could also show at the end of the session if we get some time. Okay, so this was the one thing. So inability to simulate mechanical stress is not an issue nowadays, right? So this will be wrong option. Okay, I hope you are convinced. Chittu, Rajni, you are
Sir,
convinced. I hope. Yeah. Now the last option is high cost of software. Is it true?
but it's a one-time cost, no, sir. No.
For many software, we have to renew annually.
Annually we can renew, but it's like investing cost is more. It will be hard to pay for that.
Yeah, but still, if you
Cost is
ask, if you ask any industry person, they will show, of course, software cost is certainly high. And you know what happens for industry? What is the difference between industry and academia? That they offer academia at lower price, right?
Mm.
But they offer same software to industry at a much higher price. So it is especially very much high cost for industry. In academia, what happens that they distribute institution-wise access so that they reduce the cost of the software. But still, this cost is pretty high. Like some crores it takes for this ANSYS software for institute-wise. So you imagine if you know the number of your industry, how much they pay for these softwares, then you will get to know that how much expensive it is. So it is a challenge, but it could be done like some open source softwares are also there, right? Like AFEMM in last session I discussed. AFEMM is an open source software, though it is not very much capable, but still you could do something with it. On other thing is that some softwares offer a student-based access. Like if you are a student, you could get to access those software for free with your institution email ID. So in that way, it could be managed, but still, if you are going to purchase the license, then it is going to cost you a lot. So I am keeping it in the difficulty level of 2. So the major hurdle, if you have to choose only one option out of 4, then you have to go ahead with option A from my point of view. Okay.
Okay.
Okay then. So let us move to the next problem here. Okay. Sorry.
Sir, the short part is visible, sir, but the written part is invisible.
Sorry, Chitu, I'm not able to hear you. Still don't mind. If you're using any wired earphone or something, so then you unplug it and then try to speak once. Then we'll get to know where the issue is there. Or you could type in the chat box.
Sir, could you hear me now?
Yeah. Now it is perfectly clear.
Your written part screen is not visible, sir.
Yeah. That's what I got to know now, and I'm going to share that. Yeah. So here you see all those options. Though I have verbally discussed or explained all those options, but still you could see. Like third option was inability to simulate mechanical stress, which we saw with the help of APS software, and last option was high cost of software, which is an issue, but still it could be managed. So option A would be appropriate. Okay, Chitu, any doubt here?
Yes, sir. Understood, sir.
Great.
Okay, sir.
Now the next problem is what aspect of electrical properties can if help in evaluating oh, that option A is bearing function, option B magnetic saturation, option C gear ratios, option D power consumption. So you think a bit. In the meanwhile, I'm going to fill my water. Yeah. So which option do you think is most appropriate?
Magnetic saturation, sir.
Of course. Any other option is, feasible, even possible with FEA or not?
Sir, power consumption.
Power consumption could be calculated from FEA. Uh, so power consumption, I think it is not, you could not calculate directly all the power, but indirectly you could get all the information about losses, how much losses is being happening in all the you know independent segments of the core, or but uh, see what it is doing. FEA, it will provide you all the analysis or all the results related to flux. Okay, you are going to get all the result in terms of flux. From the flux, you could calculate any parameter, right? So power consumption, I would say ki, yeah, indirectly you are getting the information of power consumption, but directly it is giving you the idea of flux level, like how much flux density or how much flux is there flowing in the machine, right? You're getting my point, what I am trying to convey here.
Yes, sir.
Like, like in AFS software, how will you get power? You have flux density, right? Air gap flux density. You will get from FEA. Now you have area, and nowadays softwares also provide area in the software itself. So you will get flux, air gap flux. Now you multiply with the current, right? With poles and all. So pi into IA directly proportional to torque. So you are going to get torque. Now you multiply torque with speed. What you will get? Torque into speed is what?
Power.
Yeah.
Mechanical
Power.
power.
So in that way you are going to get power. Now current is provided by you, or if you are feeding voltage, voltage is provided by you, right? And there will be certain current limit how much you are feeding, or voltage limit how much you are feeding. So V into IA is in your hand. You are deciding the input power. V input. So this much is the input power. This was the output power. Right. So indirectly you are giving input of power, like how much rating for the machine you want to design, and you are of course getting output power based on the simulation results. So indirectly, certainly it is providing you the information about power consumption, but directly, what information it is giving you regarding flux or saturation level, like magnetic saturation. So magnetic saturation is of course the best option among all those four, but option D is also not wrong. But again, you have to choose one most appropriate option. So you have to choose option B here.
Yes, sir.
Right. Yeah. What about gear ratios?
Sir, gear ratio, it's not required in our softwares. No, it is in some other software.
Right. And gear ratios also, it is a part of mechanical transmission system. So
Mechanical.
and for that FEA is not required. FEA is required after you know the gear ratio, then for the analysis of mechanical stress or something else, or thermal analysis, then you could do. So option C of gear ratio could be discarded easily. Now what is bearing function?
So bearing also, we are going for electromagnetic devices. No, like
Yeah,
the
but here the question is regarding FEA. So it is not restricted till electromagnetic.
yes, sir.
Like it could be expanded to other analysts as well. But here, yeah, you pointed it right, that which aspect of electrical properties can FEA help? So of course, bearing is not an electrical property, but you could do analysis of bearing in terms of wear and tear or how much it is happening with the help of FEA, but still, again, it is not an electrical property, so we are going to have to discard it. Okay, so we'll have to go with only option B. Okay,
Okay.
Yes, sir.
yeah. Now comes the most interesting problem. Question 3. So in a FEA, sometimes we use symmetric analysis. Like as I mentioned at the beginning, if we have less time, then we do symmetry analysis. We only simulate for 1/4 or 1/3 or half of the rotor or half of the machine model, and then we get the output parameters. So this question asks that if 1/3 symmetry is used for motor FEA, then this model simulation will provide you some output torque that will be how many times of net torque output. Do you have any doubt in this problem statement?
No, sir.
Okay. So I'll show with the help of software again. I'll try to show you here. For that, again, I'll have to present my screen. Yeah. So here you could see, yeah. So this is the symmetry we were talking about. I hope you are able to see my software-based screen, right?
Yes.
Yeah.
Yes, sir.
So here we have model size. So what will happen if you could use symmetry, you could use full machine, you could use a specified symmetry like half, 1/4 or something. But here for default symmetry, what happens that we only simulate one pole pitch, or one pole rather, you can say, or one pole pitch to give you how the flux is flowing in the one pole. We will see in the simulation output also, right? So with this symmetry, what will happen? I'll go here and I'll try to calculate as per this model. It will take some time, and we will also observe the time taken by this, symmetric model and full model. And the question was, is there any torque difference or how many times reduction or increment in the torque which you will achieve with the different symmetric stimulation? So see, this is what I was talking about. So this is a symmetry based on one pole, right? Or one pole pitch or one pole pair, you could say. So here with the symmetric model, we were able to simulate it very quickly, and also we are going to get certain values. So you could see the output torque or shaft torque value is 10.4 Newton meter. So I am writing on my board, but still I am not able to show my board. I'll show it at the end. So with symmetric model. I have simulated SPM. Now what I will do, I will again simulate it with full machine. Okay. Now there is no need to get half model. Now I will get full model. Okay. So like this. So here I am not using symmetry, and the calculation has started, and you see how much time higher than earlier it will take. So from my estimate, almost double
Same.
or sorry,
At
you
output, it's a same only will come, na, sir. Means
yeah,
it
yeah.
will
Yes,
calculate at
that,
3D rate finally.
I'm trying to prove with the help of software. You are correct. You are correct. Output will come. It should come approximately equal, but with full model, accuracy increases. So slight difference might be expected, but almost same value should come.
Yes.
So this much time it took, right? It took how much time? So here you can see, right? So earlier it took 18 seconds to solve with symmetric based, and now it has taken 54 seconds, right? So almost three times it took. So time consumption in full model for half symmetry is almost 3x by 3x time consumption. Now let's go to the output data. So here uh, the value you must be able to see, which is 10.392 Newton meter. So earlier it was coming 10.4 Newton meter. Now it is 10.392 Newton meter. Why? Because accuracy has increased by a while, right? And yes, and this accuracy will also be reflected in all the torque profiles. So the graph would also be more accurate compared to, or more, it will have more data points compared to the symmetric version, but almost you are going to get the same value. Okay, so now coming back to my initial screen, any question regarding this software?
No, sir.
Okay, yeah. So earlier it took 18 seconds and now it took 54 seconds. So 18 seconds, 54 seconds. Right. So almost thrice time it took for to simulate almost double the symmetric of the model. So initially we solved with half symmetry, like one pole pair was required. So for that half symmetry we had to use. In the next model we used full machine and it took thrice the time compared to the symmetric model and it gave much accurate value. But to answer the question which we had in front of us, that how many times of the net torque output will provide if you are simulating with the help of one third symmetry. So no matter how many times or how much scaling you are doing on the symmetry, like if you have a, let's suppose, six pole pairs and you are simulating for one pole pair only, which means one third, right? Or no, one sixth. Like let us assume you have six pole pairs, right? And you are simulating only for one pole pair. So how much times you have done the scaling to simulate the machine? 1 by 6.
Um,
So 1 by 6 model you are simulating, but still you are going to get the exact same value or approximately same value what you will get by simulating full machine, right? So this symmetrical model is very useful to reduce time consumption or to get initial idea what kind of output you are going to achieve. But full model is required to get the accuracy of the simulation. I hope it is clear to you, right?
yes, sir.
Sir,
Yeah, go ahead, please.
so
this is applicable only for torque. Is that anything like that? Like for simulating full model also gives the same torque, and simulating as a symmetry also gives the same torque.
Right.
So only the torque can be calculated by using the symmetry model, sir.
Oh, you are asking only the torque could be calculated or other parameters also could be calculated, right?
Yes, sir.
Yeah. All the other parameters, so far I am able to think all those parameters will be approximately same. Nothing is going to change. Apart from accuracy, all those parameters will hold true until and unless in some machine model, what happens that you know a structure changes from one pole to other. Like in those scenario, this symmetry may not work, right? You are getting my point. Like let's suppose you have a rotor and you have four poles based on four magnets. So one pole has thinner magnet width, other pole has thicker magnet width, like this, like this. It is really a good question you asked. So see, you are able to see the difference in poles, right? Poles structure.
Yes, sir. Yes,
Uh,
sir.
So here symmetric model will not give you accurate answer or accurate values. So here you must have to simulate for full model because here symmetry is not present in the rotor structure itself, or rather if you can create difference in the stator. So sometimes what happens that in many research paper also you will find that asymmetric model or asymmetric structure structures are used generally to reduce certain harmonics or torque ripple or many things. So in those scenario you will not be able to get the exact answer from the symmetric model, right? You got my point. Otherwise, if it is symmetric, if it is uniform and symmetric across the pole, right, then symmetric model will give you exactly or approximately same value corresponding to the full model.
Yes, sir.
That okay? Yeah.
Yes, sir.
Good question. Eva. Yeah. Now, the next question is question 3, 4. Question 4. Which of the following statements about meta modeling techniques is true? Meta modeling is used to replace the need for original model entirely. Okay, so first option is meta modeling is used to replace the need for original model entirely. Second option is meta models are typically more computationally expensive than original models. C is meta models are created based on a small number of initial model evaluations. D is meta modeling is only applicable to linear system. Okay. So this is regarding meta modeling. What is meta modeling? Okay. So meta model is, you know, have you modeled any machine with certain circuit or certain equations? Like there is a course or there is a book. There are books also based on modeling of electrical machines. So if you could model any computationally expensive models with the help of mathematical models, right? That is called as meta models, basically. Why is it done generally? To reduce the calculation time, right? Like let's suppose ki you are spending 1 day to simulate one model, but somehow if you model that system with either equation or certain algorithm, so what you could do, you could change instantly or you could observe then and there with that model, right? Like uh, we
That
used
is
to model. Yeah, sorry.
analytical modeling, no? Analytical
Analytic
software.
analytical model, yeah. So what happened that you could model any machine or any motor with certain circuit like magnetic equivalent circuit, right? So with the help of that, you could reduce your time. But analytical model were based on theory. But nowadays these meta models also could be extended to AI based, like certain AI based software like Office Langs are there, or certain softwares where what you could do, you could make a model. So there are certain example like response surface model. So you could go and search for response surface models, which is also very famous with the name of RSM. All right. So what happens with such kind of models, that you could see entire range with those models, like where your output will lie if you change these parameters, right? So in that way, it is very helpful, and these meta models are really useful in optimizing your machines. So basically, indirectly, Office Lang kind of optimization based softwares, they use such kind of models. So you will get to see, and I hope Rajni, you have gone through the Office Lang software, I guess. Then you must have seen this topic, or otherwise, if you haven't, then you go and search, and you will be able to see. So there, it is very useful. So what was the first option? Yeah. So meta modeling is uh, used to replace the need for original model entirely. So what do you think? Is this option correct? To model any machine or any system, first we need original model, right?
Yes, sir.
So here, original model could not be replaced, right? So original model is required. So option A should be wrong. Now option B is meta models are typically more computationally expensive than original models. Is it true?
Expensive means what exactly it means, sir?
Uh, Expensive. So see, it from this statement, it is being conveyed that these meta models will take more more computational resource than original model. Like I said initially, to simulate original model or any model, if you are going to need 1 day time per model, then its iteration will take higher time. So will meta model take more time than that or less time than that? So here the option B is that it is computationally expensive than original model. Now I hope you got the point, right?
Yes, sir.
Yeah. Kitu, you got this?
Yes, sir.
Yeah. So what do you think? It is correct or wrong?
Actually, meta model takes less time. No, sir.
Exactly. In the beginning only, I told you meta model, the entire purpose of meta modeling is to reduce computational effort, right?
Yes,
Yes,
sir.
sir. Yes, sir.
Yeah. So once the initial parameters are fed into the system, then all the process is much faster than the initial, right? So this option is also
Wrong.
incorrect. Now option C is meta models are created based on a small number of initial model evaluation. So see, to develop meta models, to initialize the meta models, we need certain values, right? So since original model is required, certain initial model evaluation is required. Like let's suppose you are going to design any machine or any motor. So how much torque do you need? So to initialize with dimension of the machine, initial values are required, right? So still there are requirements for initial values so that this option is appropriate. Like what do you think?
Sir, I think option C would be appropriate.
Yeah. And another thing is that the more uh, I'll explain in terms of like any data analysis, right? The more you have data, the more accuracy it will give. And so uh, if you have certain models, like let's suppose you have initially simulated your model with 4 5 different iterations. The higher the data your meta models will receive, higher the information it will receive, it will tend to converge more easily towards the requirement, right? So that initial data are very important for these meta models. So the more data will be there, the better. But some initial data is required to develop these kind of models. So option C is correct, right? Option D is meta modeling is only applicable to linear systems. So all our machines are non-linear. So if it exists only for linear system, then it cannot be useful to us, right?
Yes, sir.
So option D is wrong.
Wrong.
Any doubt here?
No, sir.
Okay,
No, sir.
then let's move to the next problem. It is okay. It is a big question. I should have copied it, but there is no provision to copy into this software. But anyway, uh, it Okay, so question 5, which I'm going to explain here. If you could access the question 5 of the current week's assignment, actually both problems are same. So I'm going to write this problem, but since it is a big problem, so you may not be able to understand, but from there also you could refer. So you could open your NPTEL current week's assignment also parallelly. If you could, I'll try to draw here entire question. So the question is the induction motor design factor.
He screamed to identify.
Right. So you have opened it. Chitu, are you able to see this problem?
Yes, sir. I'm opening it parallelly.
Okay. By the ones that most significantly affect the torque output. A 2 raised to power 3 factorial
Experiment
experiment
three factors.
with 3 factors. So factors are air gap length,
Length,
second is stack length,
width,
third is material.
but
Right. So experimental experiments with these 3 factors have been conducted. Now the result of experiments are follows. So for the result, you could refer that table if you have opened, both of you.
Yes, sir.
Right. So you see the table, right?
yes, sir.
Yeah. So now, based on the results, which factor appear to have most significant effect on tensile strength? Tensile strength.
Here minus one plus one in the sense minus one means like
Yeah. So here, what -1 means, it has negative impact on that. Means it is reducing that parameter.
so air gap length.
Air gap length. Yeah. So you are saying option A only. So in option D also air gap and material both are there. So you have two options, right? So you have to finalize one. So see here what is happening that uh, in first simulation, uh,
3 are decreasing. Air
yeah,
gaps material.
with help of air gap and in the stack length. So as we are reducing air gap and stack length and C is material. So all are low, right? And that is leading to a torque higher. So one thing is that if -1 is corresponding to air gap length, which means the air gap has lower value. -1 means low value and +1 means high value. Here we have to read it like that. So low air gap is better for electromagnetic performance. On the other hand, low stack length will give you low torque. So uh, yeah, so here let me write it. Lower is preferred.
For
Yeah,
air gap length.
higher is preferred. And material has low performance, so of course higher will be preferred. Yeah, other way around is to do what? So corresponding to air gap length, which has +1, right? air gap length which has +1, we will take average of all the +1 side, and we could take average of all the -1 side, and we will calculate average value of torque, right? So in that fashion, it would be easier to evaluate. So what we will do, corresponding to +1, how much is the torque? So 40, right, plus
+1.
45. Yeah, corresponding to +1 only I am taking, and finally I'll divide it by a total number of samples considered. So in run 6, it is again +1, 55. In run 8, it is again +1, so 60.
60.
Divided by 4. So it will come out to be how much? 60,
50,
40,
sir.
100. 50 you are saying?
Yes, sir.
100,
50.
200, yeah, 50, 50. So it is coming out to be 50, right? Now, here gap had minus, corresponding to -1 will be equal to 35 plus 30 plus 25
25
plus
plus 50.
50 divided by 4. How much it will come out to be?
35, sir.
35. 35 Newton meter. Now, to observe overall impact of these two scenarios, what we will do, we will calculate difference between these two, right? And we will take average of that. So overall impact of air gap will be equal to how much change is happening between +1 to -1, from higher to lower. So that will provide us the exact data. So 50 minus 35 divided by 2. So it will be 15 divided by 2, 7.5 Newton meter of difference. Every difference is coming from the high to low air gap. Okay. Now, second factor we will evaluate, and this overall impact, wherever it will be higher, that will have most significant impact on the output. Now, second is a stack length. So
Yes, sir. 35. This one first.
yeah, corresponding to a stack length. So for +1,
+1. Okay, sir. Then 30,
+1 is 30,
45,
45,
50,
50,
60.
60. So it will come out to be 60, 90, 95, 185 divided by 4.
46.25.
46.25, sir.
5, yeah. Corresponding to -1,
Hmm.
35,
55,
yeah,
40,
yeah,
25,
25,
55.
55. Yeah,
38.75, sir.
38.75.
75.
Yeah. So now we have to calculate overall impact, which is 46.25 minus 38.75 divided by 887,
3.75, sir.
3.75 Newton meter. Right.
Newton meter.
Yeah. So compared to 7.5 Newton meter, it has 3.75 Newton meter, right? So almost half. Half is the impact of the stack length. So obviously this option will be excluded. Now option C is material. Yeah. So again, corresponding to +1, is last four, right? 25, 55, 50, 60.
25, 55, 50, 60.
Yeah. One 10, 50, 70, 190.
47.5
One.
Newton
Yeah,
meters, sir.
190 by 4, I guess, right? 47 point. Now corresponding to -1, it is all the above four. 35,
40,
40,
30,
30,
45.
45,
37.5, sir.
37.5.
5.
Yeah. So now overall impact will be 47.5
Minus 30.
minus 37.5 divided by 4. So it is 10 by 4.
2.
So
2.5.
oh, 2.5 only. Okay. No, sorry, do 2, not 4,
Divided
2.
by 2, no,
2.
2.
Yeah, yeah. So it is 5.
5, sir. 5
5.
Newton meter.
All right. So now, which factor? So we had options as air gap length, stack length, material, or last option was air gap and material. Right. So option A was
Okay.
air gap. Option B was stack length. Option C material. Option
Maybe
D
both
both
air
air
gap
and
length and material.
yeah. So what do you think should be appropriate?
Both.
Option A, sir.
Option A is definitely correct. Like air gap is certainly
B.
playing huge role, but option like material is also playing a crucial role here, right? Like almost 5 Newton meter difference is there. So 5 Newton meter difference is
Yes, sir.
huge. On the other hand, 2.5 Newton meter or 3.75 Newton meter is the has the lowest impact. So we should go ahead with both
D.
option A and option C. So option D.
Okay, sir.
So option D should be correct for this question. Okay. Yeah.
Sir,
Now, yeah, please go ahead.
is there any range like limits? This is the maximum limit, and this is the minimum limit of that.
Okay.
Because for
Huh.
material it is 5 Newton meter, and for air
Yes.
gap it was 7.5.
Huh.
So compared to material, air gap has more significance, sir.
Exactly. Exactly. Air gap has most significant impact here. But you see, the maximum torque is 60 Newton meter. From the table, you could be able to observe that maximum torque is 60 Newton meter. Right. And in 60 Newton meter, the difference of 5 Newton meter. So how much percentage? 5 by 60 into 100. So 100 divided by 2. So it is 8.33%. Right. On the other hand, in the first case, air gap, it is 7.5 Newton meter. So 7.5 divided by 60 into 100.
12.5, sir.
12.5%. And regarding the stack length, it was 5%. 5, no, 3.75. So it is 6.25. Yeah. So what you have asked or what you are saying is definitely correct. But again, machine design or any advanced design course has certain things that you have to, it completely depends on you only, right? It is not objective based, it is completely subjective. It varies from requirement to requirement, what do you want, how much impact do you want, right? So, like, if uh, you want to have optimum performance, then of course all three factors would be correct here, right? ABC, because 6.25% lose in terms of torque is also not, you know, very low. It is also significant. But, uh, you know, it is completely subjective type of thing. So you have to choose whether 8.33% is high enough. And on the other hand, why we convert on the option D? Because option D was mentioned. If there had been other option which mentioned that all three factors are playing, significant impact on the output, then we would have chosen that option as well. You're getting what I'm trying to say here? That if
Yes, sir.
the options would have incorporated all three, because all three has impact on the output, then we would have chosen that. But since here only these two options are given, then it is more appropriate to choose, these two. Right? So it is completely subjective. It completely depends on one's prudence, how much one is willing to trade off between one parameter to other. So that's all from my side. I hope that clears your answer or doubt.
Yes, sir.
Yeah. So next question, sixth question is, which of the following statements about design of experiments, which is also known as DOE, is true? Option A is DOE is used only in the initial stages of product development. Option B is, sorry, option B is DOE aims to maximize the number of experiments, experimental runs required. Okay. Option C is DOE helps in identifying the significant factors affecting the response. And option D is uh, DOE is used only for linear system. So these are all options, and this is the question regarding DOE, design of experiments. So what do you mean by design of experiments? The first thing.
Uh,
Yeah.
We are taking few of the parameters in consideration and continuously like varying that value in certain limits.
Right, right. So, uh, you know, to evaluate the which factor is going to play a major role in your experimental validation or test, right?
Yes, yes.
Right. So, uh, this design of let us focus on the first option that DOE is used only in initial stages of product development. So it should not be correct, right? Because it is also used in the final stage also, because uh, if any factor is affecting the performance during the final test also, then also this design of experiment is very helpful, right? So this option is DO is applied only in the initial stage of product development is incorrect.
Yes,
DOE is applied throughout the product testing, from the
that's correct.
initial design to the optimization to the troubleshooting, right? It is
Yes,
going to be used throughout the process. Okay. Now,
yes.
second option is DOE aims to maximize the number of experimental runs required.
No, sir.
So, no, basically it minimizes the number of,
Minimize.
right, because you are identifying the major factors, so hence you are minimizing with the help of certain optimization process like Taguchi method or some factorial fractional methods like that. So you are minimizing the total experimental run. That is the primary objective of this DOE. Okay. Chitu, you are also getting these points.
Yes, sir.
Yeah. If you have any doubt, feel free to stop me in between and we can discuss that. Now, the option C is DOE helps in identifying the significant factors affecting the response.
Yeah, this correct, sir.
Yeah. Why is it correct? Because
It's help.
its primary objective. Yeah, go ahead, please. You were saying.
Yeah, please, sir. You can continue.
Yeah. So its primary goal is to identify the factors, right? So this option itself, uh, it states that it helps in identifying the significant factors affecting the response. So of course it has to be correct. Now, what about last option?
It's only used for linear systems.
Yeah, is it correct? Because a response surface method and all optimization based system are non-linear. So if it is working for only linear system, then what is the point of using it, right?
Yes, sir.
Yeah.
Yes, sir.
Okay. So in practical scenario, like when you are going to design any motor, let's suppose you have you know you have initialized the motor design with all the parameters, and what you are observing during the optimization session that let's suppose your material is playing a critical role in your performance, or rather say performance in terms of output torque only. You want to optimize your torque in the machine. Okay, then what you are going to do, that you will only focus then on torque because all other parameters are set. Now you change the material and you focus on the material, and like that design of experiment factor is air gap here. Sorry, air gap is material here, right? And that material will be considered as a major factor for DOE. And you change this material and you see all those output parameters, mostly it is torque, which we are concerned with, and you could see the difference, right? So you could search also, or you could see what are the examples of DOE, other examples. There are various examples. Like just before we solved that table based question, right? So that could
You
be also considered as a DOE kind based problem. So their major factor was major critical factors were these three parameters: a stack length, air gap, and material. So then we will be only with these three DOE factors. I hope you got my point, what I'm trying to say.
Yes, sir.
Okay.
Okay. Mm, so what is the next problem? Yeah, seventh. So consider a design process where the torque ripple content of the motor depends on two input factors. One factor is bore diameter, which is represented with x1 in mm. Option second is operating speed, x2 in mm. Okay, a response surface model RSM is built using a central composite design with three center points and two levels for each factor. After concluding experiments, the following model is obtained for predicting torque ripple. That model is kind of like this: 80 plus 5x1 minus 3x2 plus 2x1x2 minus 0.5x1 square. Okay. Now, if you are given with certain bore diameter, like bore dia is 150 mm and the speed is 20 meter per second, then can you calculate this torque ripple?
Yes, sir.
Yes.
Okay, so please calculate it. Okay, I'll just take a 2 minute break and I'll be back. In the meanwhile, you calculate and Okay, so can I get the value?
26.738.
26.738. Okay. Any other value, Chitu? Let us calculate it in the meanwhile. 80 plus 5x1 is 150 mm, so 0.15 minus 3 into 20 plus 2 into 0.15 into 20 minus 0.5 into 0.15. Yeah, 26.7385 it is coming. Oh, X1 in mm. Okay, I don't know why in the solution in X1 they are directly using the value of mm instead of using in converting in it into meter. They are directly using in mm and they are getting answer equivalent to 85. So maybe from the question, did they mean that
They told it
X1?
bore diameter in mm.
Yeah, they told bore diameter in mm.
Yes, sir.
And so does that mean that we have to use that directly in this equation? Maybe.
Maybe, sir. Yes, sir.
Yeah.
They given no.
Yeah.
Then
So then we have to directly plug in the value of 150 in this equation.
Sir,
Yeah.
speed is in meter per second, no, sir?
Yes.
all are must be SI units.
Then either we should convert speed to millimeter per second, no, sir?
No, no, no. I
No,
don't think they are referring like that. They are referring ki these are the parameters described in such a SI unit. You have to take it straight away. You do not need to convert into a standard SI unit. You just take it straight away. Like they are saying ki
Yes, sir.
X1 use in terms of mm and X2 use in terms of meter per second. Okay. So basically what they want ki you use all those parameters as it is because this response model is giving you in terms of whatever you are feeding in as input. So you are feeding generally in the motor model or in any FEA software, we generally feed in terms of only. So that's why that might be one reason. I'm not sure.
sir. Even though if
Yeah.
you 15. Answer is not correct, sir.
Yeah. It must be coming out like 44.
4,000, 4480.
Yeah,
4,480.
80. So in both way, it is not coming correct. What to do? I don't know. Anyway, what could I recommend? I could recommend go ahead uh, with a standard SI unit, and that value seems to be appropriate, right? That value, whatever came, 26.738 Newton
Yes,
meter, seems to be appropriate rather than this insanely negative value. So you stick with your this option. I hope. I wish ki next week I am not going to hear that this option is wrong, but I have a strong intuition that this option will certainly come out as wrong. But anyway, we can sort it out later on when solution will be released. Okay.
yes, sir.
Yeah. So basically, this problem here is to illustrate the use of RSM-based models, that you will get your output in terms of certain equation based on certain factors, and depending on this equation, you could, what to say, it will not take much time to evaluate the value. Like you wanted to get torque ripple. Let's suppose here you want to get lower torque ripple further than 20.738. Then what factors you will have to tweak? So that idea you will get easily, and that's how optimization or meta model and all plays a very important role. Right. So now next question is, an electric model with following FE analysis is given. So those parameters I am going to write. So rated voltage is 415 volt. Power is 3 kilowatt. Power is always output. Rated speed is 1500 RPM. Number of poles is 4. During FE analysis, it is found that torque ripple is 5% at rated speed. So what should be the peak to peak torque ripple in terms of Newton meter? So peak to peak torque ripple in Newton meter. So how can we calculate it?
They given torque
Yes,
ripple
sir.
5% rated speed.
Yeah. So torque, first we have to calculate the torque, right?
Yes, sir.
And
Yeah.
and after that we could calculate the peak to peak difference between the torque. So first let us calculate the torque. So torque omega is equal to power. So torque will be power by omega,
Omega.
which is nothing but power by 2
2
pi
pi m by 60.
n divided by 60. So power is 3 kilowatts, so 3000 into 60 divided by 2 pi into RPM is 1500. So it
1500.
will, yeah, so it will come out to be into 60 divided by 2 into pi into 1500. It will be 19.09.
098.
So this much torque we have calculated. Now for peak to peak torque ripple, right? So this percentage is given. So this percentage will be peak to peak torque ripple. So this percentage torque ripple definition is what? Peak to peak torque ripple in Newton meter, right? Divided by average torque, which we just calculated, into 100%. Does it make sense? Torque ripple, this expression does make sense? Percentage is nothing but, see, this kind of waveform of torque, let's suppose you have. So this is the peak to peak, right? This is the peak to peak. And if it is said it is 5%, which means this T1 minus T2 divided by whatever average will come out into 100%. So this is what meant by percentage of torque ripple, right?
Yes, sir.
So T1 minus T2 is, we have to calculate this, we have to calculate, and percentage torque ripple is given as 5%, right? This X or this peak to peak divided by T average is 19.09 into 100, right? So now we can calculate peak to peak value. Torque of peak to peak value is 19.09 into 5 divided by 100. So how much will it come out to be? It will come out to be 0.9,
0.9544.
9.4 Newton meter. So with it does make sense also for 90 Newton meter of torque, 5% torque ripple means approximately 1 Newton meter of torque ripple will be there, right? I hope no doubt is here, right?
Yes, sir. No doubt.
Yeah. Let's see a final problem that using 20 data points, a polynomial regression model of degree 2 is fitted to predict uh, is fitted to predict the efficiency of PM motor. Okay, the coefficient obtained from the model are like that. Coefficient of model is like that: 100 minus 2.5 x1 plus 3 x2 square. Okay, so why this y dash is nothing but uh, predicted efficiency. X1 represent permeability of PM, and X2 represents current density. Now, X1 and X2 is fed with the value X1 is equal to 10 and X2 is equal to 2. What will be the predicted efficiency for this meta model, right? So this kind of meta model coefficient you can get from the software or from the analysis, and permeability of PM is provided as 10 and current density as 2, though these are not a practical values, but still, if you will fit such kind of values in this equation, so what value of efficiency you could predict, that is the question here, right? Efficiency definitely depends on the current density, that is correct, but current density is not generally as low as 2. So that's why I said 2 is not a appropriate option, and permeability of permanent magnet is not higher than 1.01 or 1.05. So 10 I did not feel like a correct option, but still, if such type of problem you will face, then you can calculate this efficiency of the machine like 100 minus 2.5 into 10 minus 3 into 2 square. Okay, so how much efficiency are you losing? 25 minus, oh sorry, this is plus, right? 3x2 square is plus. 3x2 square should not be plus, because no meta model should provide you in positive of efficiency in terms of current density, but fourth is 1200 plus 12 minus 25.
87.
So 87%.
87.
Yeah. So you just see how is the model equations are provided in the problem, and you further, I believe it will be easy for you to just plug in those values and get the answer, right?
Yes.
So only such type of problems are there in the assignment. If you have any other doubt, we could discuss. I hope you will be easily able to solve all the assignment problems.
Yes, sir. All are easy.
Yeah. Okay, then it's time to wind up. Thank you very much for joining.
Thank you, sir.
Good night. Bye.
Bye, sir. Bye.
Thank you, sir.
Thank you.